Okay, so we're going to try a couple more of these. And then we'll look at how to do something like 10, and then one like question 20 as well. Okay, so let's try one more of these at least, maybe two if we need to. Let's look at 68. And 68 is 6z to the fourth plus z squared minus 1. So, what do we look for here? Well, we look to see if anything will come out. Nothing comes out. We know that because that 1. So now we take the first times the last. 6 times a negative 1. That makes it a negative 6. What do I know about the signs? Are they different or are they the same? Okay, they're going to be different. Which one's larger, the positive number or the negative number? Positive number is larger. Why? Because the middle number is positive. Can someone tell me what two numbers multiply together to give me a negative 6, subtract from each other to give you 1? Okay, positive 3 and what? Positive 3 and a negative 2, right? Because 3 times 2 is what? Positive 3 times negative 2 is a negative 6. That's what we want. And 3 minus 2 is a 1. Because remember, there's no number in front of that z squared. So if you want to, you can put the 1 there. You don't need to, but you can. Now what do? We split the middle up. And now we've got a 6z to the fourth. We've got a 3z squared. We've got a minus 2z squared. And we've got a minus 1. Does it make sense now?
Yeah.
Okay. First two pieces, what can I factor out? I've got a 6 and a 3. So 3 comes out. And looks like a z, what? Z squared, isn't it? And that's going to then leave you with a z squared. Sorry, 2z squared. Don't forget about that, because 6 divided by 3 is a 2. So 2z squared. And then this completely comes out, because that 3z squared came out. And if it completely comes out, what do you always leave? You leave that 1. Okay, so there's that. What about the next two pieces? Well, nothing can come out, but what does it begin with? A negative. If it begins with a negative, what do we always factor out? A negative. Nothing else comes out, we factor out a 1. So we're going to factor out a negative 1. That is going to switch my signs. And that's going to make it 2z squared plus 1. These are the same. And that's 2z squared plus 1. 3z squared minus 1. Now let's look at one that's like question number 20. So it's going to kind of look like, what we're going to look at is one that's going to kind of look like this. It's going to be different. We're going to factor something different out, but it's going to be like question 20. So this is going to be like question 20 in homework 5.2. Let's look at 72. And this again is on page 356. So we've got r squared and an r minus s. minus 5rs times r minus s, and then a minus 6s squared times r minus s. Okay, so when we first look at this one, it looks a lot more complicated than what it really is. So the very, very first thing we look at is we see if they have something in common. Now, it might be a number in common, it might be a variable in common, and it might be a set of parentheses that's in common. If I look at my parentheses, what do you notice about all the parentheses? Are they the same? Yes. Okay. They are exactly the same. So that's going to come out. So I'm going to take out an r minus s. And if I take out an r minus s, that is then going to leave me with, if I cover it up, r squared, cover it up, minus 5rs minus 6s squared. Now, if you look at question 20, while you're copying that down, let's look at question 20. See, look at question 20 in your homework. What do these all have in common?
A plus B.
Quantity squared, right?
Yeah.
So you're going to take out on question 20, you're going to take out an A plus B quantity squared. And then you'll factor it, just like we're going to factor this one, just like we factored all the others. We put our 1 in front. 1 times a negative 6. That's a negative 6. So it's negative. One number's positive, one number's negative. Larger one in this case is negative. And what two numbers would work? What two numbers are going to multiply together to give you a negative 6, subtract from each other to give you a 5? Yep, I think someone said it. Not because they have to be different signs. One positive, yep, one negative. Someone said it. 6 and what? 6 and 1. So negative 6, positive 1. Larger one is negative because the sign in the middle is negative. Now we split the middle up, nothing new at all. This is just like all the others that we've done so far. So we're going to split that middle up again. So we're going to go ahead and split that up. And we're going to make that then r squared minus 6rs plus, and you can put the 1 there if you want to, or you can just write that as rs minus 6s squared. And now we've got enough of these. Hopefully we should know what to do. What can I factor out of the first two pieces here? Can someone tell me? Yep, r comes out, and what's going to be left over? R minus 6s, isn't it? Next two pieces, what comes out?
S.
S can come out. What's left over?
R minus 6.
Yep, S, right? Because we've got an S squared. S comes out, so it leaves you with a 6s there. Now, double check and make sure. Are these the same? Yep.
Yes.
We know we did it correctly. So then out in front, we've got an r minus 6s. Then we've got an r plus s. And then do not forget, in front of all of it, what still has to come down? Don't forget, the r minus s comes down at the very end. Just got to remember that's there at the top. You just bring it down, and that's your final, finished, complete answer. So factor out what's in common. Like I say, on your homework on question 20, you're going to factor out an a plus b quantity squared. It's easy after that. one like question 10, that's going to be a little bit more difficult. And we're probably going to have to do 2 of these. So these are going to be like question 10 in your homework 5.2. We're going to do 2 of these. We're going to begin with question 61. These are definitely the most challenging. They're not really difficult. You just have to keep track of things. And make sure you write it all down correctly and don't lose track of any of the different parts. Okay. So we're going to go through this one and the next one slowly so we can see how these are done. First thing I always do is I look and I see, can anything factor out? No. I automatically know nothing's going to come out because of the 1. So we know nothing's in common. Now, it looks a little bit different, but let's think about what we've got. What do we have? We have how many terms? We have 1 term, 2, 3 terms, right? Terms are separated by addition and subtraction, so we've got 3 terms. How do we handle 3 terms? We take the first times the what? Last. That gives you a 10. 10 is positive. So they're either both positive or both negative. Now, which one do we have? Are they both positive or are they both negative? Look at the sign in the middle. What's the sign in the middle? Negative. So these are both negative. Okay. We should be able to see it pretty quickly. 10 ends in a 0, right? So that means we can try multiples of 5, or maybe 10 itself. What if we use 5? 5 is 5 and 2, and 5 plus 2 gives you then what? 7. Is that what we need? Yep. Okay, so what are we going to use? Minus 5 and a what? Minus 2. Yep, because we need to make sure we get that negative. And we can check because minus 5 times minus 2 is a positive 10. That matches. And minus 5 minus 2 is a minus 7. And that matches there, doesn't it? Always make sure it matches. Okay, now this is where it becomes a little bit trickier. So we are going to split up our middle. So at the very beginning, we have a 10 times k plus 1 quantity squared. We're going to take that minus 7, and we're going to split it up into a minus 5, and we keep that k plus 1 with it. So minus 5 times k plus 1, then minus 2 times k plus 1 plus 1 on the end. So we split it up. Even though it's got parentheses, we split that up, okay? Right into this. Now we think about how we're going to factor. Now when we factor these, you might end up taking out a set of parentheses instead of a variable. Let's first begin with the numbers. We have a 10 and we have a 5. So 10 and 5, they have a what in common? 10 and 5 have a 5 in common, so that's going to come out. What else do they have in common here? K plus 1, don't they? I'm going to use square brackets just because we've got so many parentheses, and I think it'll be confusing if we use multiple parentheses. So let's try to use the square brackets here. Now, what's going to be left over? Well, 10 divided by 5, that's a 2. We have a k plus 1. We have 2 of them. One's coming out, so you're left with a single k plus 1. Right? And then what about the last piece here? These are the same. Negative 5 divided by positive 5 leaves you with a negative 1, doesn't it? What about the next two? Well, they don't have anything in common. But what does it begin with, though? Negative. So let's take out a minus 1. And that's going to leave you then with a 2 times k plus 1. And watch your signs here. Positive 1 divided by negative 1. That leaves you with a negative 1. Do the square brackets, do these match up? Yes, they do. Okay, now, we're going to go ahead and clean these square brackets up a bit so we can deal with them. So let's go ahead and try to clean these up. Because we've got to distribute through and we've got to combine. So we need to clean up this part here. So we've got 2 times k plus 1 minus 1. Distribute your 2 through. So that's going to be a 2k plus 2 minus 1. And that is then a 2k plus 1. So this actually comes down to be, when you distribute it through, 2k plus 1. And you can make them parentheses now if you want, and you can see what's in common. Okay, because that condensed down to that. You can leave the square brackets if you want to, or you can use parentheses now. When I look at this, okay, look and see what we've got in common. Are these parentheses now the same? Yes, those are exactly the same. So that 2k plus 1 comes out in front. You can use parentheses again or square brackets. I'm going to use square brackets. The square brackets are just going to make sure I don't use a lot of extra parentheses. And they also make sure I remember that I've got to clean this up a bit. So now what do we have? We have 5 times k plus 1, right, minus 1. Because that's gone and gone there. This has to be cleaned up a bit. So we've got 5 times k plus 1 minus 1. Go ahead and distribute your 5 through. And that's 5k plus 5 minus 1, which is then 5k plus 4. So that gives me then for my final answer, 2k plus 1. This here became 5k plus 4. And that's it. Like I say, these are, I think, the most difficult. I only gave you one of them. It's just keeping track of all the different pieces. Yep, just got one of them, though. Let's try 64. Let's look at 64 now. And then we'll move on to the next section, which the next section is different, and I think you'll find it to be a little bit easier in many of the problems. Question 64 is 4 times x minus y, quantity squared, minus 23 times x minus y, and then a minus 6. Okay, so it doesn't look like anything will factor out. And nothing's going to factor out. And I can tell that because we've got the 4, we've got the 6, and then we've got 23. Well, 23 is an odd number, and it has nothing in common with the 4 and a 6. So nothing's going to factor out of it. So now we're going to look at this as a 3-term type of question. First times the last. That's a negative 24. You know, one number's positive, one number's negative, middle number's negative. Now I'm going to show you something that you can use in many different questions here. Look at the number inside the box, 24. Look at the number in the middle, 23. What's the difference between them? They only have a difference of 1, right? That means you're going to have a factor of 1. If the difference between these two is ever 1, you've got to have 1 as the factor. Now, we know one of them is positive, one of them is negative. So I'm going to use a negative, larger one, because the sign in the middle is negative. Smaller one is positive. And so difference is 1. So how about a minus 24 and a positive 1? That'll work, right? Again, look at the numbers. If they have a difference of 1 between the middle and the number in the box, you've got to have a factor of 1 in there. Now we rewrite. And we've got 4 times x minus y, quantity squared, minus 24 times x minus y, plus, we don't have to put the 1 there. You could, but I'm not going to. X minus y, and then we've got our minus 6 there. Just split it up. And you could put the 1 there if you wanted. I'm not going to, but you could. Now, what do we know about the first two? Okay, what do they have in common? We've got a 24 and a 4, so they have a, what numbers in common here? 4 and 24, they have a, not a 6, they have a 4 in common, don't they? What else do they have in common? Okay, x minus y. Okay, I'm going to use square brackets. You can use parentheses. I don't like to have a whole bunch of extra parentheses because it's confusing. So here I'm going to use square brackets. Now what's going to be left over? This one's actually easier than the last one. 4 came out, right? That's gone. X minus y, they're squared. So one of them came out. So an x minus y is left over. What about the next piece? 24, it's negative. 24 divided by 4, that's a 6. The next two pieces, these have absolutely nothing in common. If they have nothing in common, you can always factor at a 1. And so that leaves you then with an x minus y, because it's still there, and a minus 6. And like I said, this one's actually easier than the last one, because nothing is going to go together. That's the nice thing about this one, is nothing's in common. Nothing can go together. Because when I look at my square brackets, x, y, and a 6, nothing's in common. So that's just going to leave you then with an x minus y minus 6. They're the same. We don't even have to break it down because those are the same. What's left over then? And let's go ahead and distribute that 4 through when we go through as well. So what do we got? When we distribute that 4 through, we're going to get 4x, right? Minus 4y from that piece. And then what else do we have from the second part? Plus 1. And that's your final, fully factored, finished answer. Now we're going to move on to 5.3. And in 5.3, we're going to be looking at how to factor two terms. And when you have two terms, you're going to use a special formula. So when we go to factor things that have two terms, we factor them using a special formula. Now, they're either going to be squares or they're going to be cubes. We'll do the squares first, and then we'll look at cubes. To do these, we need a table of squares. This way we have it for reference. So let's just make up our table of squares. Okay. 1 squared is 1. 2 squared is 4. 3 squared is 9. We need our squares here. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared, I believe, is 121. I always like to double check and make sure. Okay, 121. And about as far as you ever need is 12 squared. And 12 squared is 144. So when we work these out, we're going to need to reference back our table of squares, because these are all the squares. Now, with the squares, we're going to look at a difference of squares. And these have a specific formula. They're very simple. Squares are easy. Cubes are a little bit more complicated, but not much. So we're going to look now at what's called a difference of squares. And for your difference of squares, I think they use, x and y. Okay, so they use x squared minus y squared. Well, that comes out to be x plus y, x minus y. And this is our formula. Okay, now, when we talk about the difference of squares, the most important part of this formula is the signs. That's what we need to worry about. We notice that one is positive and one of them is negative. To use a difference of squares, they've got to have two terms, and everything has to be squares. So we'll start off with a really, really basic one here. And we're going to try and factor this out. Okay, so first off, to factor this out, if this is a difference of squares, the sign in the middle better be negative. Is the sign in the middle negative? Yes. Yep. If it's positive, you cannot factor it. It has to be negative because all we have for squares is a difference of squares. Now, cubes we'll look at later, and they have a positive and a negative. But squares, all we have is a negative. Now, when we look at this, let's see if this is a square or not. Well, we look at our first piece, 25x squared. Is 25 a perfect square? Yep. Okay, so 25 is a perfect square of 5 and 5. And then the exponent, we've got to make sure we can split it in half. Okay, so the x squared, we can split that evenly into x and x. And what about the second piece, 121? Is that a perfect square? Yes. Yep. It's a perfect square of 11. So that's 11 times 11. Now, these are our numbers. And this is all there is on these. These are our numbers. Now, look at how it factors down. See, it's got parentheses. So we use parentheses. And one of them is positive. One of them is negative. And what are my two numbers? Well, 5x and 5x. So I write it first. 11 and 11. One of them is positive. One of them is negative. And that's a difference of squares. try another one. Difference of squares is not difficult. It's one of the easiest things that we have to work through. Let's look at this one. Okay, we're going to try and factor this one out. Well, when I look at this, I think, okay, is this going to be a difference of squares? It could very well be. And I know that because is 9 a perfect square? Yep. Is 64 a perfect square? Yep. Okay, so let's go ahead and break them down. We've got a 9x to the 10th. We know that 9 is a perfect square of 3 and 3. And what about x to the 10th? Can we split that in half? Yep, we can make that x to the 5th and x to the 5th, right? And what about our 64? Y to the 8th. Well, 64 is a perfect square. If you look back up, what's 64 a perfect square of? 8. So that's 8 and 8. And then what about y to the 8th? I'm going to split it in half. Yep, and that's going to be y to the 4th and y to the 4th. How do the signs go? One is positive, one is negative. And so we need a 3x to the 5th and a 3x to the 5th. 8y to the 4th, and an 8y to the 4th. And that's it. So very simple on that one. Let's do one more, and then we'll look at things that are not differences of squares. And we're going to talk about why they're not differences of squares. And then we'll look at perfect square trinomials, which are also very easy. So we'll do one more of these, then we'll look at several that are not perfect, not difference of squares. So this one is, let's do this one. How about we look at 50 x to the 9th minus 2 x. Okay, so let's look at this one. Now, when you first look at this one, you may think, well, 50 is not a perfect square, is it? But before we do anything else, irregardless of the problem, we need to see if we can factor something out. And in this case, I've got a 50 and I've got a 2. So can I factor something out? Yep, looks like I can take a 2 out. And what else do they have in common? An x. So a 2x comes out. Now, when I factor out that 2x, then that leaves me with a 25 x to the 8th, right? And a minus 1, because that comes out there. What about the 25 x to the 8th? Is that a perfect square now? Yes. Yep. Okay, how do we know it's a perfect square? 25 is a perfect square, and is the exponent 8, does that divide evenly by 2? Yep. So it's 5x to the 4th, 5x to the 4th. Now 1, what do we know about 1? 1's the only number that is a square of itself. So 1's a perfect square of 1 and 1. It's a difference of squares, so how do the signs go? Plus and minus. Do not forget what's out in front of it to begin with. Is that 2x? So that comes down. How does it split up? 5x to the 4th and 1 and 1, right? Easy enough. And that's your final, finished, factored answer. let's look at a couple of these and let's talk about why these next ones are not going to be able to be factored. Why they're called prime. If I give you this one, this is prime. Now, why is this one prime? Why is it not factorable at all? Why is it already factored for us? Well, 49 and 12, do they have anything in common? No. Okay. Now, 49 is a perfect square, but we have a problem because is 12 a perfect square? No, 12 is not a perfect square. So we can't do anything with it. And this is prime. Why is it prime again? It's prime since 12 is not a square. So it's not a square, and that's why. If it would have been, let's say, a 16, then it would be factorable, right? You'd be able to factor it, but 12 is not a square. This one's also prime. On the next one here. You may think this one can factor, but this one's also prime. And why is this one prime? It's prime since x to the 9th power cannot be split up evenly. Okay, whenever we look at these exponents, they have to be even, meaning you have to be able to split them in half evenly. And x to the 9th, I cannot split in half. Okay? I can split into 4 and 5, but I can't split up where they're the same. Like, if that would have been x to the 8th, I would be able to factor it. Because in x to the 8th, I could factor that down into 4 and 4, right? X to the 4th, x to the 4th. So that one's prime because of that. Then we have this one. This one is also prime. And why is this one prime here? Well, when we factor these squares, what are we looking at? We are looking for a difference of squares. This is a sum, right? And this is prime since it is a sum. Okay, so it's prime since it's a sum. Now let's look at some perfect square trinomials. And these are called perfect square trinomials, and they're very similar to the difference of squares, but they work when you have 3 terms. Perfect square trinomials are either positive or negative, and the positive gives you a positive square out, and the negative one gives you a negative out. And these, by the way, just so you know, these are going to be in your textbook on page 357. So these are going to be on page 357 here. And they're going to work just like the difference of squares. They have to be perfect squares again. Okay, let's not use an x. Let's use a z. We'll use z squared here. We need x squared z and 5 times 3, and how about a 30 in the middle? Okay. Now, we could factor this one like we factored all of the others before break. We could go through that process. Now, for this one, it would take a few minutes to try to find the numbers, because you have to take 25 times the 9. You have to try to find out the numbers. But when we look at this one, before I try to factor it like I did in 5.2, I look at this and I say, well, 25 is a perfect square. 9 is a perfect square, isn't it? Right? And what's the sign in the middle? Positive. Okay, so this is what's called a perfect square trinomial. Now let's figure out what's going to go inside of our perfect square trinomial. So the ends, they have to both be squared. And 25x to the 4th, well, 25 is a perfect square of 5 and 5, right? And x to the 4th splits up into x squared and x squared. And then we've got the 9z squared. Well, 9's a perfect square of 3 and 3. And z squared splits up into z and z. Right? Now we've got it. So the ones that involve special formulas are actually very easy to work through. So now we know that this is simply going to be 5x squared plus 3z. That's it. That's it, because it's a perfect square trinomial. If it was negative in the middle, then we would know our answer would have a negative in the parentheses. So let's try another perfect square trinomial. How about 16 y to the 10th? We'll use a minus here, and then we'll put a plus over here. And let's use, how about 121? And let me get the middle so it'll work. Okay, so we'll put an 88, y to the 4th, or sorry, y to the 5th in the middle. You don't have to worry so much about the middle, because it'll already be given to you. But when we look at this, we think, oh, this is probably a perfect square trinomial, because 16 is a perfect square and 121 is a perfect square. Now, if you didn't realize that was a perfect square trinomial, you would have to take 16 times 121, and that would give you 1936. And then you would have to try to factor it. Okay? So, if you see that both numbers are squared, then it's a perfect square trinomial. And you don't have to do all the work from 5.2. So always check first the first number and the last number and see if they're perfect squares. And they are. So that's going to come down as a squared here. And we've got 16 y to the 10th. Well, that's going to be a 4 y to the 5th. We split it up. And a 4 y to the 5th. And 121 is a perfect square of 11. Sign in the middle is negative, so that comes down as a negative. And we've got 4y to the 5th and a minus 11 in the middle. That's it.
Okay, can I ask a question?
Sure.
Why did you say again that we have to multiply 16 times 121?
Okay, if this would have been like 120 and it was not a perfect square, how would you go to factor this? Okay, if it wasn't a perfect square, then you would have to take the first number times the last number, right? And you'd have to try to find all the factors. If you didn't realize that 16 was a perfect square and that 121 was a perfect square, then you'd have to find the factors, right? But if you realize hey, these are both squares, then I can jump to my answer. It's a perfect square trinomial. A perfect square trinomial is going to save you a lot of time. So instead of having to try to find the factors, if these are squared, you can jump to your answer. Okay? A lot of times with these factoring questions, it's just a matter of how do I approach it. And there's different ways of approaching it. One way might be a lot easier than the others. Like realizing that those are perfect squares, that's going to make your life a lot easier. Let's do one more. And let me put some numbers out in front here. Okay, so 9, let's say 324. How about x to the 9th? And we'll do a minus, and we'll do a plus here. About 196. This one's going to be x to the, yep, just put an x there. Okay, and then in the middle, because you always have the middle. I've got to make sure we got the middle that comes out correctly. Okay, so we have 18. Oh, sorry, 9 times 4, which is 36, and 36, let me check the other one. 96. Okay, divide that by 4 is 4, so 7 times 4. Okay, 7 well, let me just make sure the middle will come out. You always have the middle, you won't have to do this, but I've got to make sure that it'll come out right. So that's times 4. Okay, times 36, double it. Okay. 20, 16, x to the 5th here. Okay, so let's look at this one. Now, this one you would think would be very, very difficult to factor. When I look at this, I say, I see that these all have an x, so I know at least an x is going to come out. And chances are, if an x comes out, then more is going to come out. And I want to see if I can get these to be squareds here. So what I can do is I can factor out an x, and what about 324 and 196? Well, I think these both have a 2 in common, right? But I think they might have a 4. You always want to take out the largest number that they have in common, and I think they'll have a 4. Because 324, when I divide it by 4, okay, that's an 81. That tells me I'm on the right track because 81 is a perfect square. And 196, when I divide it by 4, what is that? 49. And that's also a perfect square. So we're going to take out a 4x. And so then 324, we're going to divide that by 4, and that's going to be an 81. We've got an x to the 9th. We're taking 1 out, so that's going to be an x to the 8th. Minus, and then we've got 2016. Divide that by 4 as well. That gives you a 504. X to the 4th. And then we've got a plus, and we've got a 196. We're going to divide that by 4, and that's a 49. So by factoring out the 4, look at what now has happened. I factored that 4 out, right? And now I see 81's a perfect square, 49's a perfect square. So I now know it's going to factor. And I always like to write the squares over to the side. So 81, x to the 8th. 81's a perfect square of 9 and 9. X to the 8th is x to the 4th, and x to the 4th. Then we've got 49, and 49 is a perfect square of 7 and 7. Sign in the middle is negative, so the negative comes down. And we now have a 9x to the 4th. Minus 7. And what's out in front of all of it? 4x. And that's it. But see, if you didn't realize that that 4 could come out, you wouldn't see the fact that it is a perfect square trinomial. So you've got to make sure that if it's there, If there's a number in common, factor it out. And once you factor something out, you may start to see that it is actually a square. We'll do a couple more of these. Then we'll take a short break, and then we're going to come back and look at cubes. Okay, let's look at another one here. Let's look at, still along the same lines, let's look at this one. And I'll just pick this from our textbook here. I could make one up, but I'll just pick this one from our textbook. And this is on page 361. And we're going to look at question 16. All right, so this one is a difference of squares. You may not think about it as a difference of squares, but it is a difference of squares, right? We have two terms, and this piece is a square, and 9's a perfect square. It is a difference, so let's see how this would factor. If it's a difference, we have a positive and a negative. It doesn't matter which one goes first. When I look at h plus k quantity squared, well, that is h plus k and h plus k, right? There's two of them. And then what about 9? 9's a perfect square of 3 and 3. So what's going to go in the first two blanks here? Well, these are always the same, right? And what are they going to be? They're going to be these two, which is h plus k and h plus k, right? Because we split it up. And then what about the last two? What are they going to be? 9 split up into what? 3 and 3. There's your answer. Okay, that's it. Because we could take that entire grouping, since that entire grouping was squared, then we can just split it up this way. Okay, condense it down. Let's look at another one here. Let's look at one where you've got to factor it several times. Question 20. Well, in some of these, you may have to do it multiple times. You may have to factor it, and factor it again, and factor it again. And for question 20, we've got a to the 4th minus 625. And if you've got a large number like that and you think it might be a square, just use your calculator to check. Okay, if you think 625 is a square, you can always just check in your calculator. So just use your square root key. And the square root of 625 is 25. Okay? So if it's a larger number, and if you're in doubt, if it's too large for the table, just use your calculator and check. So that tells us then that this is a difference of squares. A to the 4th splits up into a squared and a squared. 625 we used our calculator on, and that was 25 and what? 25. If it's a difference of squares, we know we have a positive and we have a negative. That gives me then a squared and a squared for the first blank, 25 and 25 for the second blanks. Now, this one, we can go again. The first one, we cannot factor it anymore. Why not? Because it's a sum of squares. We need a difference. Has to be a difference or it won't work. So this one is a difference over here. And what do we know about 25? Well, is 25 a perfect square? Yep. So this one can go again. So how would this one go again? Well, a squared is a and a, right? And 25 is 5 and 5. And so that's going to be an A and an A, 5 and a 5. And do not forget about the first piece, which is an A squared plus 25. And again, why can the A squared plus 25, why can it not break down as well? It can't go any further because A squared plus 25 is a sum, and we need it to be a what? We need it to be a difference for it to work. Okay, let's take a short break, and then we'll come back and we'll look at cubes. So let's take a short break, and let's meet back here at, let's say, at 10:55. We'll meet back here at 10:55, and then we'll try to get through the cubes today.